Hey guys, welcome to today's lesson. I hope you've been going okay with your work. Today we're looking at solving quadratic equations. Now again, for you boys, this should be revision. You did this in year 8, I believe, and hopefully you've gone through some of this work already. If you haven't though, I'm going to start from scratch, so don't worry too much. Look, first of all, what is a quadratic and then what is a quadratic equation? So first of all, hopefully you remember something that looks like this. When something looks like this. There are two different types of equations. One is a quadratic and one is a linear. Can you remember which one is which and why? Well, hopefully you remember that the first one is what we refer to as a linear equation, and the second one is what we refer to as a quadratic equation. Okay, I might make that a little 2 there just to be careful. Now, these two different equations, why is it linear, why is it quadratic? Well, because the leading term has a degree of 1. Okay, the leading term in this case is an x to the power of 1. 1 is linear. 2 is quadratic. Okay, and when we have a linear equation, often we only have one answer, whereas with a quadratic, we can have up to 2 answers. Sometimes we have 2, sometimes we have 1, sometimes there actually is no answer. And of course, those graphs associated, we remember a linear graph looks like a straight line, whereas a quadratic looks like that parabola shape. And again, you may or may not have gone through that. If not, no worries. Okay, so we're going to look at some different ways in order to solve these quadratic equations. Now, there are lots of different ways. There are some methods called the cross method. I don't particularly like, but it's okay if you like it. There's what we call the product and sum method, or the PSF, product sum factors method. There's a variation where you actually use a division method in there. There's a quadratic formula method. There's a completing the square method. There's lots of different ways to solve equations. Sometimes you might be limited to what you can do, and you might have to go down a certain pathway. But you're generally not asked to solve using a particular method, except occasionally in 9 and 10, they might ask about through the method of completing the square. Apart from that, it's up to you. So if you know how to solve equations, quadratic equations, these are our questions that we're going to be looking at today. You're certainly most welcome to pause and then go through those questions. Otherwise, if you want to follow through, most welcome to. Okay, let's go. Okay, so question 1. There are a couple of different methods that we can choose when doing this. Number 1 is I always look for factorization. Okay, I think factorization is really important. Looking through a common factor is one of the very first things, no matter what method I'm choosing with factorization, that I'm going to look for. In this case, is there a common factor? Well, actually there is, right? There's an x that goes into x squared and 3x. There are only 2 terms. Therefore, we can factorize the x out. When I do that, we now have 2 factorized terms. Now, you may or may not remember something called the null factor theorem. Okay, now what that theorem looks at, if I have 2 numbers, let's say a and b, when I times them together and the product equals 0, one of 2 things has to happen. Either the a must have equaling 0, because 0 times anything equals 0, or the b must equal 0, because anything times 0 makes 0. And so we have 2 solutions that might make this equation correct. A must equal 0 or b must equal 0. And so that's really important, right? Because if we can create some type of equation where we have a product of 2 terms and the answer equals 0, we can use that null factor theorem to find what those values are going to be. So if I look at this, I do have 2 products, right? I have that first one, which is an x, or a binomial, let's say, binomial product. I have another product there, timesing together, of course, because I can't see it, but we know it's there, and the result is 0. So one of 2 things must be known. Either x, that first term, well, that straight up could equal 0, or the second term, which is x plus 3, that could equal 0. And we have these 2 possible solutions. Of course, I can solve a bit better or simplify that second solution. we have x equals 0, and if I subtract the 3 across, of course, we get x equals minus 3. And they become the two solutions to this particular question. Now, later on, what we'll look at, we'll draw or sketch the graph of this parabola, because it's a quadratic, and what these two values are, they are actually the roots, or they are the solutions or the x-intercepts of my parabola. And my parabola looks like this. We've just looked at simultaneous equations as well, and we can say that we're actually solving this simultaneously because we've got the graph of x squared plus 3x, which is this little function, and we've got the graph of y equals 0, which is a horizontal line, and we're finding the points of intersection by solving it simultaneously. There's lots of ways you can kind of think about this. What we need you to do is to be able to solve it algebraically, and then later on we'll pour in all that kind of function stuff that we're going to learn later on. But I'll still keep on talking about the x-intercepts because I think that's a really important point. So again, for these questions, what we're looking to do, we're wanting to factorize, and then once we factorize, we solve using the null factor theorem, and we go from there. If you want to pause this, by all means, go ahead and just answer all the questions and see how you go. Okay, so the second one. Now you'll see that there is no common factor, apart from one, of course, which we know isn't going to help us too much. Could always factor one out. But we also know that there are three terms, so something else is happening. And this is where we have a quadratic trinomial, I guess you might call it, because there are three terms here, okay? And it's a quadratic function. So what we are looking at is how do we factorize this? Now, as I said before, you might know the cross method off by heart. I'm going to use the product and sum method or the PSF method. So you might remember this from earlier on, where the product and sum comes from. The product is the first number times the last number. 1 times 2 is 2. The sum is always that middle term, which is 3, okay? Product, of course, means times, and sum means add. So what I'm trying to identify with these two numbers, I call this the scaffold. We're trying to find two terms, okay, that multiply together to give 2 or add together to give 3. So multiplication is probably easiest first of all, because 2 times 1 makes 2. It's the only possible combination we have. And lo and behold, 2 plus 1 makes 3. It works out really nicely. Now, hopefully you remember how to factorize. You did this last year when you were kind of factorizing quadratics. Now, you might also know that this is called a monic quadratic, which means, it's monic because of the 1 there, it means that we can go straight to our factorized form. We can write x plus 2 and we can write x plus 1 straight away in our brackets. Now, a side junket, this is going to make a long video, but I'm going to do a side junket. If you didn't know how to do that, we could split that 3x and split the terms and split it into 2x and 1x. And the reason we do that is because when we actually split that middle term, okay, we create something that we can now factorize. X goes into both terms, x plus 2. 1 goes into both terms, x plus 2. And if you remember when we did this, if those brackets were the same, they are now common. I factorize that common element out. And then when I factorize that common element out, we're left with the x plus 1. And look at that, that's exactly what we have there. Any monic quadratic you have, you can cut it out though. Okay, you don't need to do the long process unless it's a non-monic, which we'll see very shortly. I'm just going to get a bit more space there. Okay. So last year you did a lot of that factorization, you should know that. Now, because I've got two terms, again, I'll circle the two terms, and they're being multiplied together, the answer is 0. We know each of those two terms must equal 0. So I could write x plus 2 equals 0, or x plus 1 equals 0. I'm going to subtract the 2, so x equals minus 2, and x equals minus 1. And they are my two solutions for this particular question. Okay, now of course you don't need to write that first line. You really should know that minus 2 plus 2 makes 0, minus 1 plus 1 makes 0. You get your answer straight away. Of course, if I then refer this to a quadratic function, we have the intercepts of -1 and -2, and that would be my nice parabola. and I go back to the original function, the y-intercept is plus 2. Look at that, a beautiful parabola. So again, I'm going to keep on talking about how these relate to parabolas. That's really important. Okay, we've got a lot more questions to go, and I'm already at 10 minutes, so I want to try and knock the rest over in 10 minutes. So I'm going to get a little bit faster. Question C, exact same question, slightly harder numbers. Product and sum, again, you don't need to write the scaffold out at your level of mathematics. You don't need to. You should go straight to the factorized form. However, I'm going to do it for argument's sake. Product is negative 16, sum is 6. Okay, two numbers. I'm thinking about 16 and 1 don't work. 8 and 2 look like they might work, don't they? How can 8 and 2 make 6? Well, 8 plus 2 makes 6, doesn't make negative 16. What about negative 8 and negative 2? Does that make 6? That doesn't make 6 either. 8 minus 2, how's that? Okay, a little bit of a mind blank there. Okay, so 8 minus 2 makes 6. 8 times negative 2 makes negative 16. They're my two numbers. Perfectly, I'm going to write that down. X plus 8, x minus 2 equals 0. We're good to go. Don't get too concerned by the negatives. You know 8 and 2 will make 6. How to make 6, subtract the 2, all good to go. Now, null factor theorem. Hopefully by now you should be able to look at it and say, that's negative 8 and that's positive 2. You've answered your question. Your job done. If you want to write the whole thing out equals 0, by all means. Again, you don't need to do this. However, I'm just showing it for purposes. 2 and negative 8. They're my solutions to that nice parabola, but I didn't even draw a nice parabola there, to that nice parabola. And so you can see later on the progression between solving a quadratic equation going into creating a nice parabola. And I think that's quite important to know. But certainly these questions, we're just solving, okay? All right, let's go to D. Now, each time I'm trying to up the ante a little bit, okay? I'm trying to up the ante a little bit. So, again, if you need to do scaffolding, by all means do it, but you should start to test yourself so you're not doing the scaffold. I've got a product of 4 and a sum of negative 5. So my two numbers, the first thing that points out to me is one of them has to be negative, okay? The other problem is the product must be positive. So the only way I can have a product being positive and one of the numbers being negative is if they're both negative. So I'm going to look at 4 and 1 because 2 and 2 can't make 5, but 4 and 1 make 5. How about negative 4 and negative 1? They add together to get negative 5. They times together to get positive 4. They're my numbers. I'm going to straight away put x minus 4. I'm going to put x minus 1 equals 0. Therefore, x equals 4 and x equals 1. And of course, if you drew a parabola, 1 and 4 your x-intercepts, nice and easy. Okay, but I'm not going to do it. The next one. Now we start to come into the big boy stuff, okay? You'll notice the difference between E and all the other questions, of course, is that we no longer have a monic quadratic equation. We have a non-monic. It's non-monic because of this 2. This 2 causes a little bit of anxiety, okay? A little bit of a longer process we have to follow. Of course, if you're doing the cross method, you still might do it just the same way. A quadratic equation later on, you might do it the same way. But when I'm factorizing, I'm going to look for a common factor. There is no common factor, so I can't remove it into a monic, because sometimes you could. If I had a 6 where the 7 was, I could factor the 2 out and I've got a monic. Okay, but in this case, it's a non-monic. So let's look at my product and my sum. Okay, I usually do a scaffold for these kind of questions. My first number is a 2 times the negative 4. That makes a product of number of negative 8. And the sum, of course, is negative 7. Just be careful. It's always the first times the last number. Now, my two numbers, oh, they're not so bad. 8 and 1 will make 7. So let's do negative 8 and positive 1. I think that looks pretty good, right? Minus 8 and positive 1. Now, I can't go and write x minus 8 and x plus 1 because when I times the x's out, they don't make 2x squared. So I am forced to split that term. That negative 7x, I'm going to split it into negative 8x plus 1x. I mentioned before, the reason I do that is that I can then have 4 terms that I can factorize nicely. Okay. So don't forget the equals 0 on the end there. So now I can look at this and I can factor the first term and I can factor the second term. I factor the first term, we have a 2 that's common and an x that's common, which means x minus 4 is there. I got a plus 1, and in brackets, I got an x minus 4. And like I said earlier on, if those two brackets are the same, you know you've done this correctly because they are common factors. We can then factorize them out. And when I've factorized the x minus 4 out, I'm left with a 2x, and I'm left with a plus 1. And now you can say I have the two terms being times, and the answer is 0. Now, of course, if you struggle a little bit to find your solutions from this, I mean, I could look at this and say that x equals 4 straight away, and that x equals negative a half. Okay, I've done this a lot. Hopefully you get there. If you're really not sure, you can write out x minus 4 equals 0. You can write out 2x plus 1 equals 0. And then you can plus the 4. That's where I get the x equals 4 from. I'm going to subtract the 1 just like I would normally. And then I'm going to divide by the 2. So I get negative a half, and that's where I got it. Sometimes, it's like covering up the x in front of the 2 in front of the x. You would say it's x plus 1, it would be minus 1. Let's just divide the 2 out and get our answer. But there are two solutions. Of course, if you wanted to go and draw your parabola, you have x-intercepts of 4 and negative a half, sketch it through, job done. Okay, hard question. When you have a non-monic, you are forced to split that term. Okay, do a little bit more challenging method, I know, but, something you have to learn. Then the last two questions. How am I going for time? 1650. Okay, not too bad. Now, F is actually quite an easy question. It's very similar to the first question, believe it or not. But what's the issue? The main issue, it doesn't equal 0. Every other question here equals 0. If that's the case, take whatever's on the right-hand side or collate them all onto one side so you do have 0 left. That means here, I'm going to subtract the x off that side and put it to the left-hand side. I'm going to rewrite my question, x squared minus x equals 0. Okay, it's the first thing. Now it equals 0. You can do that with any of these questions, realistically. Now, common factor? Yeah, there is a common factor. There's an x. X outside of x minus 1. Nothing else I can really factorize. That means I'm almost at my answer. So looking at my question now, I've got an x that's being timed by the x minus 1, which means the first term must be 0. The second term, x minus 1, must equal 0. Therefore, x equals positive 1, and job done. Not very different. Again, I could do that, 0 and 1, and I could sketch my parabola. Okay, perfect, nice and easy. Of course, the last question is probably the most challenging. Okay, we have G. We have 3 on x equals x plus 2. Doesn't even look like a quadratic. There's no square there. So why do I know that this is a quadratic? There's also this little thing here that says x cannot equal 0. Now, it's a parameter. It's nothing to do with the question that we'll have to actually answer. But at this time, it's just a parameter. And why can't x equal 0? Well, if I sub x equals 0 into the question, we know we can't divide by 0. Okay, a lot of bad things happen when we try to do that. So it's just saying that x can't equal 0. So if you get into 0 solution, well, it's incorrect. So what do? Well, like that other question, it doesn't equal 0. Okay, and I have a divide by x. So let's try and move things to the right-hand side. I guess in one term, you could minus the 3 on x over the other side, but I'm going to do it slightly different. I don't want the divide by x on the bottom. I can't really deal with that when I try and go through my factorization. So what's the opposite of divide by x? Well, hopefully we know we are going to times the whole right-hand side by x. That means I have 3 equals x times x is x squared, x times 2 is 2x. It still doesn't equal 0, but look at this last little movement that I do. I'm going to take the positive 3 to the right and make it a negative 3. And now look at that. Can you see what you've created? You've actually created a quadratic equation that has a 0 answer, which means we can factorize it, hopefully, and then use the null factor theorem. So it's just like a little previous step that makes it easy for us. So now I'm going to look at this question. I'm going to say, okay, in my own head, I've got a product of minus 3 and a sum of 2. 3 is a prime number, so 3 and 1 are my two numbers. 3 subtract 1 makes 2. So x plus 3, x minus 1 makes 2. Now, if you needed to go and do the product and sum over here and make it minus 3 and 2, and then do your numbers that way, 3 minus 1 makes 2. You can see, it's the same thing, but I'm just trying to push myself to be able to do it without the scaffold. From that point forward, very clearly, x equals minus 3, and x equals positive 1, which again I could draw my parabola off with 1 and minus 3 and draw it through. Pretty straightforward. Look, that's pretty much it. That's how we solve quadratic equations when we are factorizing. The next lesson we'll look at completing the square, we'll look at the quadratic formula, so we'll look at other areas, but at the moment it's primarily looking at factorization. The only other thing I'm going to show you before I just finish up here, gents, is if you get this, right, and if I have something like 3 outside of x plus 1, x plus 2 equals 0, and I'm just kind of pushing it because I gave this to you in F. And I just want to kind of clarify something. I'm just going to write down f. When we factorize it, looked like this. You might get a question that says, how many solutions are there for for these two equations? And believe it or not, they both only have 2 solutions. In this one we've already done, we know that x equals 0 and we know that x equals 1. Here, x equals minus 1 and x equals minus 2. But then people have a bit of an issue because of this 3 at the front. Because in the second equation, you can see that I had an x out the front and that had a solution of 0. So what about that 3? Now that 3, guess what, actually has no bearing on my question because there's no actual letter attached to that. It's just a 3. Now, in hindsight, what you could do is to get these two things by themselves. What's the opposite of times 3? Well, that's divide by 3. And what's 0 divided by 3? It's still 0. And so you're still left with that. Okay, which means you're still going to get the x equals minus 1, x equals minus 2. It just looks a little bit different. Look, I hope that lesson kind of made sense to you. I might plug a few other videos on there to do with factorization, just in case you're struggling a little bit. But hopefully that was pretty okay. Have a wonderful day, gents, and I'll see you next time for completing the square, which is more challenging.